Alright guys, we're going to start on Unit 12, Section 4, Inscribed Angles. Our objectives are to find the measure of an inscribed angle and use inscribed angles and their properties to solve problems. Okay, an inscribed angle is an angle whose vertex is on a circle and whose sides contain chords of the circle. And here in a minute I'll show you an example of what one looks like. An intercepted arc consists of the endpoints that lie on the sides of an inscribed angle and all the points of the circle between them. A chord or arc subtends an angle if its endpoints lie on the sides of the angle. So let's look at this. Okay, so angle DEF is an inscribed circle. You have the vertex on the circle and the endpoints, okay? Arc DF is the intercepted arc, and arc DF subtends angle DEF. Okay, so we've got this theorem here. The measurement of the inscribed angle, right here is called ABC, is half of the measure of the arc angle. Okay, so here's an example of an inscribed angle where you have segment BC, your diameter. Here's an example of a subscribed angle where your A, B, and your CD are chords. And then here's an example of a subscribed angle where A, B, and CB are also chords. Okay, so we're going to apply this. Find each measure, P, R, U. P, R, U. Okay, so we want to find the measure of P, R, U. And that's not PRU. I was wondering, like, well, that's 27. PRU is right here. So let's get this right, PRU. So the intercepted arc is PU. So the measurement of angle PRU equals half of the measurement of the arc. So if we take half of 118, we get the measurement of that angle, which is 59 degrees. And then now we're going to try to find arc SP. Arc SP. Well, the inscribed angle, sorry about my phone there, but I'm just going to ignore it. The inside angle is, the inscribed angle is PRS, and that equals 27 degrees. That's given. So what we have here is we have 27 equals half of the measure of arc PS. So if I multiply this side by its reciprocal, and then multiply this side by its reciprocal, the measurement of that arc is, what is that, 54 degrees? 54 degrees. Okay? All right, kind of the same thing here. I'm going to leave this one alone and let you all try it. I will work quietly in case you get confused. Let's move on. All right, now we got a corollary here. So if inscribed angles of a circle intercept the same arc, are they subtended by the same chord or arc, then the angles are congruent. So what you have here is we have this arc right here, AB in yellow, and if you notice, you have inscribed angle ACB with the intercepted arc. You have inscribed angle ADB with the intercepted arc of AB. And you have inscribed angle AEB with the same intercepted arc. So if they all intercept this arc right here, then they're all congruent. Okay, so this one's a little tricky. We're trying to find the measure of DFA. DFA, which is this right here. Okay? All right, so what I have here is I have the measurement of angle DFA equals the measurement of angle DCF plus the measurement of angle CDF. So let's look at that. DCF is this right here, which is 33 degrees, and CDF, which is this right here. Okay, and we know this angle because we have this intercepted arc. So how can I use that to help me with this angle? Well, let me redraw that. I have this measurement, and I have this measurement, and this here is the angle we're looking for. Well, that is your exterior angle theorem. Remember when you have two and this is your exterior? So that is this theorem. So now let's substitute in what we know. Let's see, this one here is 33 degrees, and this one here is half of arc CB, so it's half of 164 degrees. And when I work that out, I get 115 degrees. So that's the measurement of angle DFA. DFA. And that's what I'm trying to solve for. Alright, we got another theorem here. An inscribed angle subtends a semicircle if and only if its angle is a right angle. Okay, so that's letting you know that if this is a semicircle, and that is your intercepted arc, then this right here has to be 90 degrees, a right angle. How do we know that? Well, if this is 180 degrees, that intercepted angle, or inscribed angle, has to be half of that, which is 90 degrees. Okay, so what we have here is we're trying to find A, and this angle measure is giving. This is an inscribed angle with this intercepted arc, which has the diameter as a chord, so this here is 180 degrees, therefore this angle right here has to be a right angle. So what we can do is we can say 5A plus 20 equals 90 and solve for A. Okay? All right, we're trying to find the measure of LJM. LJM, which is this right here. There's that measurement right there. And this inscribed angle intercepts the same arc Therefore, what do you know about these two angles if they intercept the same arc? You know that they are congruent. So on this one, on this one what we can do is we can set them equal to each other. Get our variables to one side. And we're trying to find LJM, so measurement of angle LJM equals 5b minus 7. Well, substitute in for your variable b, and you're going to get 10.5 degrees. Okay, let me check on time. And I'm going to go ahead and stop just to make sure I have time.